Hello and welcome to the latest InfoSecurity Magazine webinar. My name is Kevin Poirot. I'm a reporter at InfoSecurity Magazine, and I'm delighted to be your moderator for this session. So for the next 60 minutes, we are going to talk about securing intellectual property and industrial data. As cyber threats continue to evolve, safeguarding sensitive information and maintaining regulatory compliance has never been more crucial. When we hear about cyber attacks targeting industrial systems in the media, it's often about attacks that target operational technology because it's more frightening to think of a water system breaking down than of data theft. However, these are still very scarce, whereas attacks targeting IT systems and especially sensitive data like patents or CAD files are much more common and can be extremely valuable, extremely impactful to the victims. So that's what we're all going to talk about today. But let me first go through a few bits of housekeeping. So first, please note that this session qualifies our viewers for CP and CPD credits based on a minimum attendance time. So you will find the instructions for this in the CPE instructions document. It's in the attachment below. Also, I want to encourage anyone watching to submit your questions about today's topic to our panel using the Ask a Question tabs below as well. We have a full hour to discuss this topic, and the session is a great opportunity for you to pick our speakers' brains. And we'll also try to do our best to answer all the questions by the end of the session. So to discuss this topic, I have with me today a wonderful panel of speakers with different backgrounds in cybersecurity. So I will let them introduce themselves, starting with you, Blake.
Yeah, thank you, Kevin. Blake Wood. I'm the current VP of Global Alliances at CAD. I have a 30-plus year background in IT and security. I'm also a CISSP and a CCSP and a recovering security practitioner. So I'll be doing a short presentation for you today on CAD, data protection technology.
Thank you. Phil, what's your background?
Hello, Kevin. Yeah, thanks for having me. My name is Phil Green. I spent 20 years as an engineer working on equipment ranging from missile targeting systems through to kit used in automated warehouses and lots of different stuff in between. I self-studied cybersecurity and transitioned into the industry as a Cyber Essentials assessor, an auditor, which is a UK sort of scheme. I'm also founder of Cyber23, which acts as a certification body to support customers with their Cyber Essentials and Cyber Essentials Plus audits.
Thank you. And Peter?
Thank you. Yeah, my name's Peter Wood. I'm currently partner and lead consultant at Naturally Cyber. I'm currently in my somewhere in the 50th year of working, which is quite depressing. I've spent the last 20, 30 years in cybersecurity. Prior to that, I spent a lot of time on data communications, industrial systems, and IT in general. I also am a recovering cybersecurity professional. I guess that's such a great expression. I'm also a CISSP and a CITP, Chartered IT Professional. So I'm very much looking forward to today.
Thank you so much, and I'm delighted to have all of you with us today. Now I'm going to give the floor to you, Blake, for a presentation.
Thank you, Kevin. Thank you, fellow panelists. Let's jump right into it because we don't have a lot of time for this. But we're going to talk a little bit about critical strategies for securing intellectual property and more specifically CAD files. For all of the people out there, this is no big mystery to you. Data breaches continue to go on. There is no end in sight. What we're finding, though, is when data is shared, it's taking up to a month or more longer to discover these hacks. These are also adding, when you share data outside the organization, it's adding another almost $500,000 to an average breach cost. So no end in sight, becoming more expensive and harder to detect, especially when you're sharing data. And so why is this important, especially for the supply chain and intellectual property? what you see here is just a classic example of how IP is being stolen within the ecosystem. On the left-hand side, you have some basically some high-end airplanes, warplanes. These plans have leaked out and gotten into the hands of the Chinese. So they've been duplicating some of the features of our highest end warplanes here in the US through lost IP. And then on the right-hand side, a little more closer to the commercial market, here's an example of copying very popular automobile models, from the VW Beetle, the Porsche Macan, the Toyota Land Cruiser, can all be found as other vehicles in other countries where IP leaked out. And so this is all fueling sort of a new set of regulations. I call them promising regulations. I'm not a regulation guy. I don't believe that regulations necessarily make things better. I think they're great for establishing guidelines, but it's really about the application of regulations. And so, with this, we have in Europe, we have NIS2, or the Network and Information Security Directive 2.0, which is going to go into effect later this year. We also have here in the United States, going back to 2021, Executive Order 14028, which really started talking about the need for implementing zero trust by default, especially here in the US with federal government agencies. And then lastly, another US regulation, which is becoming a very hot topic. If you actually are a defense manufacturer here in the United States, you're going to have to comply with something called the Cybersecurity Maturity Model 2.0. And I'm not going to talk a lot about these, but just keep those in mind because we might touch on the regulatory side a little later. I keep wanting to hit my my page down button, but it doesn't take. Anyway, the solution to all this is a couple of things. Application layer data security, which I've been involved with for over 15 years now. And so, application layer data security really started out protecting structured data. In other words, data in databases. And you saw this, you can see this in mainstream products. Most of the databases have some kind of, encryption at rest feature. Some have actual encryption at the field level features, which is more of an application layer security model, which is really the best security model because application layer security protects data in use, it protects data in transit, and it protects data at rest. So going all the way back to the early 2000s, we started to see these features pop up, mostly in the database side. In 2010, we've got introduced to zero trust, which is really about creating the least permissions model for anything data or any access, basically restricting access to everybody unless they have explicit permissions. Another example that I was involved in as we talk about application layer data security, something called PCI P2PE, which is in the payment space, is really embracing that zero trust model and encrypting data at the point of transaction within the payment ecosystem. And then as we go forward into the 2020s, the modern workspace model, if you guys are Microsoft Office users or Google Workspace users, each of those has options for protecting this unstructured data, at the application layer. At Google, it's called client-side encryption. And with Microsoft 365, it's the Microsoft Purview Information Protection Platform. And I'll talk about that right now. What is Microsoft Purview? It's a large platform offered by Microsoft. If you have a Microsoft 365 license of the E3 or E5, you have access to the Purview platform. And why is this important? It's important because it's a fully functional and very large data governance, risk and compliance platform, as well as a data security platform. There's a lot of features inside Purview. If you haven't taken a look at it, you might want to take a look at it. But right now, what we're going to look at specifically is what we call Microsoft Purview Information Protection, or MPIP. And that also has implications with some of the DLP, or the data loss prevention features, that you can also find within Purview. So with Microsoft Purview Information Protection, what you get are a few things. It has a very robust data classification service. This is very important for data loss prevention. You have the ability to then classify that data and apply what are called sensitivity labels. Sensitivity labels have robust policies and functions behind them. So think of it, sensitivity labels as like a firewall rule for documents. This is all managed through something called the rights management service. So with Microsoft, you'll hear the word DRM tossed around a lot for protecting files. DRM is typically reserved for things like videos and whatnot. And so I like to think of this more as a data loss prevention or a data protection play. Anyway, this is available with all Microsoft 365 documents, Word, Office, PowerPoint, etc. It's built into the actual applications. But when you have, and also a lot of the Microsoft cloud services, the Azure platform, all of that. But when you look at other applications outside of the Microsoft world, for instance, CAD or SAP ERP system, they have no connection to this platform. And so the question is, what can you do about that? There's something called the Microsoft Information Protection SDK, or MIP SDK, and that is a way to integrate third-party applications so that they can participate in this very robust platform. And so for today's talk, we're really talking about a tight integration between CAD applications and the Microsoft Purview Information Protection Platform. And the really great thing about this is what it does is now we have the ability, and this is all within the rules that you can define, the policies and rules for the sensitivity labels, actual application features that you can turn on or off. View, edit, copy, paste, print screen, which is really important for CAD files. Because you can set this in the Microsoft Purview platform, we can extend that into the CAD application itself and actually stop things like that. We can stop someone from being able to edit, being able to print screen right at the CAD workstation. So this is a huge advantage for third-party apps by integrating. So I'm going to jump right into the CAD application use case and what we've done at Secud. We have a product called HaloCAD, and HaloCAD plugs directly into the CAD workstation and something called a PLM system or a product lifecycle management system. So we cover both of those platforms. In the simplest form, working from the CAD application itself at the workstation with our HaloCAD plugin, that plugin is actually communicating directly to the Microsoft security services in the Microsoft 365 cloud. And because we've integrated this at the CAD platform, now we're able to introduce files that are non-Office files into that. All of these different file formats that are very specific to a plethora of CAD applications. You can see them all listed down here. I won't go through them in painstaking detail, but the bottom line is we extend beyond the Microsoft 365 native documents, Word, PowerPoint, Excel, etc., and we extend that into these CAD application specific documents. The way this looks in a CAD workstation is just like this. This is where we have what's called the sensitivity label bar. And so this is an actual Secud feature when you have a HaloCAD installed. In this case, we're looking at Dassault SolidWorks. This is how an engineer will choose a sensitivity label to attach to a document at the time of creation. What we also do is for companies that use product lifecycle management or PLM systems, we do automatic data categorization or data classification and sensitivity labeling at the PLM system. So as an engineer is checking out a document, And this is how it all works. At the CAD application itself, which is talking to the PLM system, when that engineer is checking out a document, a file, a drawing from the product lifecycle management system, what's going to happen is it's going to classify that document. It's going to reach out and pick a label for that, attach that to it, and encrypt the document. So at that point, as it flies across the network to the CAD workstation, it's encrypted, and then it remains encrypted at the, as the engineer works on it. So it's encrypted in transit, it's encrypted at rest, and it's encrypted while the engineer is actually working on it. So this is a very powerful way to protect documents as they fly out of these product lifecycle management systems. And so how do we do this? We have a server. We call it the Halo Engine server. And it's very simple. What it does is it works with the contextual information inside the product lifecycle management system. Some product lifecycle management systems have their own level of data classification. And we tap into that and we map that back to these Microsoft Purview information protection sensitivity labels. And so as documents are getting checked out, we're discovering, through the rules, what sensitivity label that is, and we're applying it to that document, which in turn gets it encrypted and protected wherever it goes. And lastly, this will be the last slide here. What this allows us to do now is, because we've wrapped that CAD file in essentially a zero trust envelope, we have a sensitivity label on it, which defines the application features that can be accessed with this file. We can also attach things like expiration dates if we want to share that outside of the enterprise. But now we have the ability to share that file securely outside of the enterprise with third parties. And so if somebody intercepts that as it goes outside of the enterprise, it's basically worthless. The companies that you share with will have to have the secured solution at some level. There's different levels of that solution. But the bottom line is now they can access it securely, they can edit it, they can do whatever they need, and at no point can that document be compromised. So I'm gonna finish up with the presentation there and give it back to you, Kevin, and our panelists.
Thank you so much for this. So before we move on to the conversation, I just wanted to also pick our viewers' brains. I like to do that after or right before the conversation to see who are we talking to and who are our viewers. So I'm going to launch a first poll question. So the question is, what is your biggest concern regarding the security of your industrial data? And some of the options are legacy systems and outdated hardware or software vulnerabilities, supply chain or third-party risk, accidental data leaks by employees, intentional data leaks by employees, or other. And if you want to specify the other, you can use the ask a question button. And you can share with us what kind of concerns you have around that. Now, I wanted to ask our other panelists if they have any comments or any questions about the presentation before we move on to some of the questions I have for you.
So I guess just picking up a point there in the presentation, I noticed obviously some of the defence platforms, some of the aircraft in particular, and it just struck. It reminded me of the time in my engineering career when I was working on a particular platform. One of the aircraft that was pictured, the company that I worked for actually provided products into that, and it was right at the very early stages of low rate initial production. There was probably less than a dozen of those aircraft flying at the time, and it's quite, this was back in 2011 kind of time frame, and pictures started circulating of that aircraft in another country, in a foreign country that was blatantly not part of that project. So the sort of industrial espionage kind of side of it's stuff really important. And I've seen that sort of kind of with my own eyes how that can sort of play out.
Mm-hmm. Thank you, Peter. Did you have any comment on the presentation itself?
Yeah, well, apart from being really impressed by it, because it's a lovely presentation and an exciting looking product, I think in my background, sort of, I guess, 20 or so years doing various forms of what we now call red teaming, social engineering, that sort of activity. Theft of individual files was typically one of the key objectives we were set. And there's so many different ways to gain access to those files, of course. Having the ability to steal those files becomes far less important in this context if I can't actually do anything with them once I've got them. So I think, Zero Trust, when it first came onto the scene, I remember David Lacey promoting it with a number of his colleagues way back 15 years ago or so. And I thought it was a brilliant idea then, but there wasn't really any global way of implementing it. And it was just the usual 50-50 sort of, some people might do it and other people might not. To see something that hooks into what I guess we have to accept, how much we do or don't like Microsoft, what is the most important platform through an SDK is just terrific news. I'd be interested to learn how that may or may not work with the Mac platform as well. But overall, fantastic stuff and really interesting topic.
Thank you. And I wanted to maybe jump back a little and get back to the threat landscape around industrial systems. So Peter, you mentioned you have a very long career in cybersecurity. What does the threat landscape looks like when you're an industrial company, either in manufacturing, automotive, defense, or any other industrial, when you need to manage industrial systems, but also industrial data with like a lot of patents and a lot of IP and things like CAD files, obviously. What should you be worried about? What are the threat actors interested in, and how does it look like? How does the threat landscape look like?
Well, I think some of the most important issues were in fact covered in that presentation, and we're looking at nation-state actors attempting to steal IP. That's always of interest, but it is the biggest focus probably for those actors is the industrial landscape. We also, I would be looking at competitors, much as we don't like to think about it. Competitors may be in the same nation, maybe not, also looking to access this sort of information. We see opportunistic third parties as well. For example, brokers who might wish to steal the information and sell it on to other bodies. And the vulnerability landscape is particularly exciting for someone like me in the industrial space, because the nature of OT systems is such that they tend to lag IT systems by 10 or 20 years in terms of their ability to upgrade, patch, and generally be aware of security issues. So I think, sorry, my greyhound wants to join in as well. But I think, it's a really important space because the defenses aren't as good as they should be. The targeting is more sophisticated than it might be in many other sectors, and the vulnerabilities are quite significant.
And when we talk, especially us journalists, when we talk about cyber attacks to targeting industrial companies, we usually think of the Stuxnet, of the Industroyer, things that would target maybe sometimes the OT systems. And obviously having a water facility or any type of facility breaking down or not running for a few days can be quite catastrophic. But in the end, I feel like we don't see them that much. But are the likeliness of data theft, and especially sensitive data, IP, industrial data theft? Is it more common? Is that something that you see a lot around?
Yes, it's the short answer. If you want the TLDR, it's yes. I think, that's the most interesting. In the end, we go where the money is. Anybody who's a threat actor will go where the money is, and IP and that sort of data is where the biggest money is. OT hacking, is very doable. I think it's still largely at a hobbyist level, or maybe a few groups in the hacker community, but it doesn't have the same return for probably more effort. And in the end, hopping around an IT network is no big challenge for most of these sophisticated threat actors, and getting access to files, through privilege escalation or whatever, is not supremely difficult. And I have a feeling it never will be. So looking at protecting the data rather than just looking at the infrastructure becomes critical. And you might get threat actors coming through an OT network into an IT network. That could be an entry point, if you like. But what we care most about with threat actors is their objectives, and secondly, their methodologies. So objective-wise, I think, things like CAD files and other IP files are undoubtedly the most valuable targets.
So I was going to comment real quickly. So with IP, we get a new threat actor or a heightened threat actor. It's always been a threat, the insider threat, and the reason this becomes a heightened threat with IP is because somebody can pay somebody maybe a very handsome sum to go do that, and so that's one thing I like about this method. And again, application layer security is very, very robust, but the ability to wrap that file in something that, once it gets outside of the enterprise, or if somebody were to lift it off and give it to somebody else, it's worthless. And I think that's an important thing for IP.
Phil, you wanted to? So you were nodding.
Yeah, just kind of supporting what Peter and Blake have said there. Really, it's the risk reward balance, isn't it? It's the industrial control systems are generally the reward for that might not always be something that can be easily monetized, whereas the criminal gangs that are more likely to be probably more likely to be going for after IP type information. That's going to be potentially attractive. Because it's attractive, there's going to be more kind of adversaries in that space. And then the industrial control systems, it feels like that's much more of a, like Peter said, more nation state type actors who are wanting to, and the stuff that you kind of alluded to with Stuxnet. It's much more likely to be kind of nation state kind of actors. But yeah, I think the risk reward ratio from attacker is probably a key thing. And when the data is kind of encrypted at source, it makes that whole different. It just shifts that balance of risk and reward.
And moving on to some of the key challenges of securing industrial data and industrial systems. 40% of our viewers have said that their biggest concern was legacy systems and outdated hardware and software vulnerabilities. So I wanted to maybe one of you, if one of you can explain why, because obviously, we hear a lot that in industrial systems you use a lot of legacy systems of obsolete devices. Why is it such a challenge to secure? And do you have any tips or any quick wins that to maybe have a good hygiene in that area?
Yeah, well, I would say that there are a number of key factors, but again, the TLDR to quick wins is no. The biggest problem for OT systems is at an operating system level, the applications don't necessarily support more updated OSs. For example, cache point systems in the UK, it's not very long ago that they were still running NT or even Windows 97. really. And the same thing's true. If you look at any industrial environment where there are elements that comprise Windows and other elements that are very specific to OT. Typically, those Windows devices, servers or workstations, will be running an unpatched early version, because were they to patch them or bring them up to date, the applications would simply stop working. And there is no solution to that. You can't suddenly say, well, I'm not going to use that application anymore, or I'll put some pressure onto the manufacturer to update that application, because that doesn't work. And that's kind of one of the key factors, I think, that really impacts why OT systems are vulnerable. And the other is that our traditional sort of CIA, confidentiality, integrity, and availability, is inverted when you look at industrial systems. Availability transcends everything, is much more important than everything, because those systems can't stop, whether they're a nuclear power facility or making baked beans on a conveyor belt. For one reason or another, they have to run 24/7. And that means it's very, very difficult to find a window of opportunity to upgrade hardware or software.
Yeah, I think like the lead times, the design life cycles of a lot of the the equipment, that industrial equipment, it's so long. It could running into many years, depending on what sort of products it is. So yeah, that design life cycle, the designed maybe a year one, and then but it's not actually until year 5 before it's actually past its prototyping stage, maybe, and then it could be sort of years 10, 15, 20 while it's actually in service. And obviously in those 10, 15 years, operating systems have come and gone, and that makes it. I think that's probably one of the biggest challenges, just keeping the operating systems up to date. And so so those vulnerabilities, then they just found, discovered, manipulated, exploited. And if they're not in a position to be able to replace those pieces of equipment, and they sit there potentially vulnerable. So life cycle is definitely one that I've seen in my engineering career of equipment.
And Peter, have you ever performed a red teaming exercise of that kind, trying to steal IP or to steal CAD files or things like that?
Absolutely. Yeah. Having had advanced sight of your questions, one thing that came back to me that was probably relevant was a forensics lab, which the red team exercise was to simulate a criminal gang who were intending to steal and or corrupt some forensic evidence in order to disrupt the prosecution of one of the head honchos in the criminal gang, which our client believed was a genuine and realistic scenario, but not something I'd encountered before. And the key objective was to get to those files in order to be able to either steal them or corrupt them or whatever the criminal gang's objective was. We achieved that through a number of different methods simultaneously that included credentials theft through spear phishing, included access to a supposedly very secure building through an awful lot of background work to do impersonation and end up, in fact, playing as journalists, going in to interview senior members of staff, getting access to the building, and then, as you so often find, once you're inside the building, you're obviously safe and wonderful, so you can wander about wherever you like. We found unlocked labs. We could plug systems into the network, a flat network, and so on and so on. So I've also done similar exercises for large manufacturing companies where, again, the IT-OT barrier was quite weak, and that still remains true a lot of the time, of course. So you could jump from an IT office network onto an OT network, onto an industrial systems network. One occasion where we were able to take down all of their radio transmission systems and steal their core IP, and they had no way of alerting anybody because we'd already disrupted all their comms. So, yeah, we do get asked to do that, but perhaps not as frequently as we should.
Mm-hmm. And Blake, you said in your presentation that data is more vulnerable when shared, and I feel like nowadays, whatever sector you're operating in, whatever size of whatever the size of your company, you will have to share a lot of things with suppliers, partners, clients, and maybe also some of the software supply chain partners as well. What are some of the challenges of specifically with CAD files? What are some of the challenges of securing how you sharing these assets? I know you've touched on this in your presentation, but could you maybe get into more details?
Sure. Just the whole sharing outside the enterprise is probably the biggest issue. If you take the U.S. and you take the U.S. defense industry base, which is some 300,000 manufacturers here in the U.S., a lot of which are very small, and you kind of envision, maybe this supplier, builds a widget that goes into one of these aircraft or a ship or something like that, and you've got thousands of these. They have to at some point share these drawings with other third parties that are maybe up the food chain closer to the finished product. These files can be very large sometimes, and so that's another issue with sharing them. But the trend that I've seen in general is everyone's sort of falling back to this whole central data sharing model, which is it's problematic when you have operators that are outside of your enterprise. If those credentials get compromised, anybody can get in. It's very rare that you have multi-factor authentication is becoming a thing. But if you're using SMS as multi-factor authentication mode, then it's not as secure versus push on a cell phone or something like that. So just extending your IT infrastructure outside of your enterprise is the challenge. And how do you do that with partners, and what do you have to do to sync what level of permissions you're giving them versus people inside? Therein lies the challenge. And I think with legacy technology, it was near impossible to do this. I think with cloud technology, which is just a bigger centralization model, in a platform like Purview, where I can create inside my Entra ID, which used to be called Active Directory, I can extend that to include my partners. I can give them permissions through these policies, and then when I attach that sensitivity label, automatically this subset of partners outside of my organization have permissions to do something with that file, whether it's view, edit, whatever. And this makes I like I said, I've been around for a while. I used to do a lot of these sort of reorganization projects with enterprises around just their files and who can access what where. Huge projects. This consolidates that in a way that makes it manageable at scale. And I think that's the biggest difference today. And I think that's going to fuel more of this application layer data security and some of these paradigms like what we've done, which is actually integrating into an application that's creating some unstructured data that needs to be protected, and we don't want to leave that to chance as it flies out of the application. So that's
Pete,
it in a nutshell.
Did you want to add anything to that? I could see you were agreeing with some of what Blake said.
Oh, he's on mute.
Oh yeah.
One key factor really here is protecting the accounts that do have the permissions, and that's a major push for proper multi-factor authentication. I think we're not going. Sadly, we're not going to leave passwords behind anytime soon, particularly not in the industrial arena. So some form of MFA that is solid is really critical, because it's, everything hinges on the identity of the user. And, if you protected a file in this manner, which is just super excellent, then you've got to make sure that you're also protecting the identities who have permission to access that file. And that needs good discipline in the user organizations to make sure that they do protect those identities adequately and aren't just relying on single factor.
And since we're talking about data security, why are data loss prevention so critical? So the data loss prevention solutions, what are they? How do they work? And why do you think they're crucial to prevent accidental or unauthorized data leaks?
I can start on that one. It's, DLP, I'm sure it'll morph into being called something different. But just the ability, the first thing an enterprise has to do, and it's interesting, some of the stats I've seen recently is something like 70% of all enterprises don't know where 50% of their data is. Yeah. So, task number one, let's go discover all the data. Let's classify that data. What's confidential? What's a big risk if we lose it? How does that impact us financially? And let's apply technology like this to those files at scale throughout the enterprise. So that's sort of job number one, is find the data, classify the data, figure out what you need to do with it once it's classified, and then operate from there. So that's exactly what a DLP system does. And there's a lot of them out there. Purview has a feature that is DLP. There's other third parties that have excellent DLP systems. We're kind of married to Microsoft right now, but we're looking at expanding out and maybe interoperating with some other DLP systems, because there's a lot of good ones.
Phil, with your role at Cyber Essentials in the UK, does what Blake just said about companies not knowing where the data is, and is that a big concern for you in terms of the companies that you audit and you assess?
Yeah, it is really. Yeah. So Cyber Essentials is the scheme that I audit for. So I don't work for IASME or operate that scheme. I work independent to them. But yeah, definitely when we're doing those sort of assessments and audits, the biggest hurdle that those customers have to get over is being able to define where the boundary of their network is, and often it's probably the larger the organisation is, the more murky that gets. If it's a multinational organisation and they're trying to define a set scope of how they apply a particular set of controls, when that goes across countries or across continents, it makes it really challenging for the clients to kind of define that. So yeah, as Blake was saying that, I saw Peter as well giving it a big thumbs up. That's definitely something that I see in my world, where those assessments and those audits, when the clients can properly define their networks, it gives them that ability then to apply controls to their environment, and the controls really, when I'm talking about Cyber Essentials, the controls that we're looking for within that scheme, really the foundational level sort of controls. So those bits tend to fall into place quite easily. The challenging bit for customers is always sort of getting their hands around where the network is, which bit do they control, and which bit is the internet and the Wild West or whatever. So
before we move to the strategies, I want to ask you guys about some of the strategies you think are important in securing those industrial data. But I also wanted to ask the same question to our viewers. So the next poll question is: which of the following security strategies do you believe should be the #1 priority when trying to improve the security of industrial data? So some of the options are implementing a zero trust security model, tightening network segmentation and access controls, enhancing employee training on cybersecurity best practices, utilizing data loss prevention solutions, or investing in threat intelligence and vulnerability management tools. And I did that on purpose, not to put all of the above, because if I knew if I said all of the above, everyone would have picked that answer. I do want you guys to make a choice. I know that all of these are probably very important, but I wanted to know which one you think is the top priority. So you mentioned, Blake, you mentioned zero trusts. Could we maybe try a definition of zero trust? I know there's a lot of definitions around, but what do you mean when you talk about zero trust?
When we talk about files, it's really about a least permissions model. In other words, you want to not have generic permissions that are assigned to large groups of users that automatically have access to files. I think that's, and you see that a lot, especially in smaller companies. They don't have the luxury of analyzing, who needs access to what. And so a lot of times they just say, hey, here's the all of the files. So, zero trust is really about saying, hey, you can't access this unless you have explicit permissions to do so. And with this method that we're talking about with CAD files, and by the way, when you talk about manufacturing data, it's not just CAD files. It can include other types of things, bills of materials, stuff like that. And that's where the product lifecycle management system comes in, because it can house just not only CAD files, but all the supporting documents for that too. And we also, encrypt and label those as well. And so I think that's the one advantage that, say, in the manufacturing side of the house is the CAD, CAM, all that stuff is sort of going to be in a centralized, sub-organization within these companies, and more easy to identify because you have them, especially if you have a PLM system, they're usually all in there. And so that's a huge advantage. For companies that don't do that have, file sharing, and now a lot of cloud file sharing outside of their organization, that becomes a little more difficult to rein that all in. So zero trust, depending on your ecosystem, your infrastructure, how much stuff you do outside your organization versus inside. And again, it all comes down to identity. How have you, and legacy systems obviously just complicate that because they don't have the single sign-on features and things that we enjoy today with cloud software. So it depends on where you are in that cloud journey as a company. I've been kind of blown away recently to see, I had a long history in financial services, which I thought would never get to the public cloud. It's amazing to me how much of these sensitive systems are moving into the public cloud, and they're only able to do that using technology like zero trust. So it's essential for the cloud, I would say.
Mm-hmm. Pete and Phil, do you agree on the definition first? Do you want to add anything on what is zero trust?
No, from my point of view, I think that encapsulates it nicely.
Okay. Do you have any, because once we said, okay, you need to implement a zero trust architecture, then where do we start? Do you have a few tips on how to think of a roadmap to maybe get to the point where I can say, well, I've tried to implement that kind of security architecture. What are the number one things that you would do in the context of industrial systems, obviously, because as Blake said, I'm guessing a lot of things like single sign-on won't be really available on every device. Sorry. Pete, do you wanna start with that, and then maybe Phil?
Yeah, sure.
You can complement some of what.
I think the the strategy is probably the same across all environments, whether it's industrial or commercial and office-based systems. But my experience, at least, is that probably the key difference is in, and there may be some in the audience that might object to this, but anyway, is in the people. Typically, engineers working in an OT environment or in any industrial environment, we find let's say, more difficult to convince than other users to perform in a more security alert way. So user education and buy-in through really good storytelling is actually critical to get the users to actually agree with and get involved with a zero trust model. The other issues are typical across all sectors, I think, which is good analysis and prep, which goes back to what was said earlier by both Phil and Blake, which is really understanding the asset register, making sure that you know what data you've got, where it resides, who owns it, and who should have access to it. And that's horrible, boring work, and it takes a long time, but it has to be done. Otherwise, how do you decide who gets access to the individual components that we're talking about? So, I must have given this to the client presentation hundreds of times where I say, look, first thing we need to do is information asset discovery, build an asset register so we understand what the key data is. We need to define who the owners are for each of these areas or elements of information. Then those owners need to tell us who needs what sort of access to that data. And only then have you got like a framework to implement zero trust successfully.
Phil, did you want to add anything to that?
I mean, for me, zero trust is not something that I'm sort of massively involved in, but just everything that I sort of see and hear about it, I think it's just, my sort of take is to come back to the basics, get the basics right, get those really solid foundations of, as Peter said about the asset register, making sure that that's up to date and you know where that is, making sure you stay on top of your patching of devices. I think all of the points really that you've that are in the poll there, the access and egress into the segmentation of the networks, really key and important. So yeah, just I guess just building a really great solid foundation and then sort of building on that for the more specific kind of threats.
Mm-hmm. Thank you. And finally, for the few minutes left, I wanted to touch on regulations because in your presentation, Blake, you mentioned you described them as promising. Why do you think they're promising? And could you maybe dive a little bit deeper on which regulations, because you've touched on them, but very quickly, which regulations do you think are promising and what are they going to change to this topic too?
Yeah, so there's a bunch of stuff going on right now, but what I thought was interesting about both the NIS2 regulation in the EU and the CMMC regulation, which is really about U.S. federal government here, is they're very similar. There's two objectives. Let's secure the supply chain and stop the leak of IP, based on these, Chinese aircraft that are flying around with American features now. It's obviously a very high, it's got a high priority now. Countries are obviously concerned about this and sharing the data about what they want to do, sort of at a more macroscopic level. And again, they're very similar in their end goal. I'd also say with that, what you also see, especially in Europe, because we don't have this, yet in the United States, but there's a move towards, computing sovereignty or operational sovereignty, where you're having cloud operations. They're taking the public cloud model and they're moving it into sort of a enclave, a sovereign enclave. Again, this is to provide more protection for. In Europe, you have a lot more partly state-owned organizations like Airbus and other. Thales, I think, is part owned by France. I used to work for Thales, and so for those organizations, moving them into a computing environment where the boundaries are geographical. So that's another thing I just wanted to drop out there. And that was actually, that's actually been something that's a lot more recent, is just trying to, and I don't want to say air gap, but get them off of sort of the public infrastructure and into something a little more private. So the trends are all sort of pointing to the same thing. It's we have this data that is maybe at a state level is very important. It's been leaking. We can't have that anymore. How do we stop it? In Europe, they said let's do private enclaves within countries. In the United States, we don't have that option, and so it's really about using more publicly facing sovereignty controls, if you will, which zero trust is one of those. The ability to lock that down to an entity or a group of entities helps to achieve that sovereignty. So I would say they're all sort of in line with this whole movement into data sovereignty, operational sovereignty, and more control over your assets.
Mm-hmm. And you've mentioned the US and the EU. Phil, do you have any idea of what's happening in the UK? Are there similar regulations coming up?
Well, yeah, it's interesting to sort of hear Blake's sort of perspective from across the pond in their approach. I think in the UK, at least I'm going to talk about cyber essentials again, but in terms of that scheme, the UK have said that basically if you want to bid on a government contract, that you need to have cyber essentials in place. They also there's a really strong gathering momentum effort in pushing that down the supply chain as well, so that those first tier large organisations, the BAEs, the Thaleses, if they're operating for government contracts in the UK, then this foundation level of cybersecurity, the cyber essentials, they're supposed to have that, and they're also, all their suppliers are supposed to have that, and that's supposed to trickle down to those that supply nuts and bolts and washers to anything in that into that chain of contracts. So that's UK. There's other stuff obviously with Pete might be able to talk more about maybe more of pen testing sort of stuff and critical national infrastructure. There's schemes that are around to if a company is working in a certain environment within the UK, then they've got requirements for pen tests. Sorry, I don't mean to put you on the spot, but I guess that's probably something that's more in your work, Peter, perhaps.
Peter, did you want to add anything to that?
I don't think so.
Okay.
Really, there's not a lot to add to what these two guys have said. Thank you.
Well, thank you so much. I'm afraid that's all we've got time for today. Thank you to all you guys for joining us, and thank you for the viewers for joining as well. So just wanted to let you know that our next webinar will be on the 11th of July, and we will be discussing how to make threat intelligence more actionable for your cyber defenses. Thank you for joining. Have a good day. Bye.
Thanks. Bye.
Bye.
Thanks. Bye-bye.